time the video is hands-on, the nitty-gritty of stuff. I'm showing you me using the small language model. Basically, this is like, chatting with AI, but this is a small one because this is just running on CPU. Really, like the spec. This is just a laptop, AMD Ryzen 9. Literally just reading the specification right now. So this CPU, nothing's too amazing, but yet it can actually provide a sensible result in a fairly speedy time. So before we actually try this thing out, uh, we just need to make sure that the template of the conversations is right, especially because we are actually chatting with the AI. So it needs to have separations between the user and also the assistant, which is where the result will be. So if we just take a look here, there's several prompts template from multiple kind of models, as you can see, and this one is, mm, I don't know, not really sure. Ah, this one looks like this. So when it's user, it's just prefixed with this, and when it's assistant, it's prefixed with this, right? And for each of the conversations, it will be ended with the separator, which is s. So you've got user and then the text, um, this kind of HTML separator, and an assistant, and then user, etc. So it just goes like that. And it has also the system prompt, which just happens in the beginning. So when it actually runs the the neural network, or like the small language model, it's not like large anymore. There's 3 billions. What I'm using is MiniChat 3 billions, and also it's quantized. That's why I'm using the Llama CPP Python. It's quantized, which is awesome. I think the bloke from Hugging Face, do check him out. The bloke, if you want this gguf quantized file, and this is much smaller than what the original is. Although the original is already small, it's just 3 billion or 1.5. This is 3 billion, as you can see, and quantized to 5 bits, right? 5 bits, 5 bits km. This gguf is always the one that's recommended. So let's continue. So let's just try it out. Easy, right? So this question is actually me when I'm trying to use this for RAG, right? So we put the title coffee, and then let's say, okay, now we've got the context. So I'm feeling energetic. What can I buy? So what will be the result? And the context is important because if I just write, I'm feeling energetic, what can I buy? It will give completely different result than when we actually give the context, right? So ideally speaking, this will come from the vector database, and then we've got this one as the question. Here are some suggestions. So as you can see, the first one, it just gives us directly the caffeinated beverages to purchasing coffee. Do note, like, this is pretty fast, running entirely on CPU, no GPU, and it's just 3 billions. Just as comparison, the large language model, the one that you're familiar with, is around 7 billions above. 7 billion is already like very small. So I would say average 13 billions is, so 13 billion. So this is 4 times smaller than what we would normally use. This is pretty good. And I stream it out also. You can really see the code here. You can duplicate the code also. I'm thinking if I actually I can. So all right. So this one I just downloaded from Hugging Face, and then the rest of the things is just an example for Llama CPP. Of course, there are a little bit of adjustment so that it works, but it's not really a lot. So this is one important thing, because we need a template, because what's inputted to the LLMs not actually the original question, but also already templated. So that's just the most important thing. All right, so this is the result, and then we can also try. a lot of things when we want to use this LLM as a tool, then the output has to be formatted uh, in a certain format. And in this case, I want to format it as JSON so I can actually process it directly. And then we've got directly just an array, right? And the array will represent the products. So it will just give 5 products, which is formatted in this kind of array. As you can see here, by the way, so it is waiting because first of all, it has to process the prompt, right? So after the prompt, then it can continue, right? Because this is the next token prediction. So process the prompt, then continue. So that's why we were waiting a little bit in the beginning. And then after that, because it's streaming, we don't actually feel as if it's slow, you know. It just runs this way. Product, granola bar, protein shake, coffee or tea, nuts and or seeds, fresh fruits. So it's exactly outputting what we want in a time that is manageable. If you see here, 45 seconds seems a lot, but actually, because it is streaming, then it doesn't feel too much. So very important when you are dealing with this kind of large language model, or in this case, small language model, but language model, that streaming is much better because it's like me talking, right? If I talk and then you just you just wait until the end of my speech and then you just consume it all at once, then you have to wait a really long time before you actually can know what I'm talking about. But this is like streaming, same thing. And then, oh my god, I don't have a girlfriend, how to get a girlfriend? So I'm just asking this kind of question too, just random question and see what we got. So this is the shortest out of all, so that's why the processing of the prompt is also faster. So you can see here, be yourself, of course. Authenticity is a key. Always be yourself, guys. I don't know if this is relevant to the video, but be yourself. Show genuine interest, ask questions, take the initiative, be respectful, communicate openly. You see, even AI knows what to do with girls. Build a connection. That's true. Be patient. That's true. You see, also. Oh. Anyway, I just want to show you also a little bit in details about this one. So as you can see, the runtime of so this sample and prompt, I think it's when processing the actual prompt, and it has different time than when it's generating the solution, right? When it's generating the solution, it's slower, and when it's trying to ah, this is from FL time is actually the one processing the prompt. And what is prompt is just the text that you're inputting as the question. It's much faster. It's around 2 times actually, close to 2 times the speed, because it's just you already have it and then you just process everything at once. Meanwhile, in FL time, you processing one by one. It's, roughly, it's like that technically. All right, and sample time, not really sure. I think it's preparing for the weights or preparing the prompt. Not really sure, but you can take a look further online. I saw it already on GitHub or some sort. So this is, yeah, this is a short video. I think it's not that short now if I check the time I spent on this one, but it's pretty fun. The cool thing about this is it runs on CPU and it's fast enough for us to get a proper result in a matter of seconds. So it's not too long, and we can definitely use it in embedded system or cloud when we have a lot of users. So I deeply believe this kind of small language model is the one that is actually useful and practical for the use cases that we want in the world, because it doesn't take significant time. So you can scale this one. Okay, thank you.